Welcome, Dr. Jason Hill. Jason, the floor is yours, and please start your presentation of today's 24th of January. Jason.
Thanks, Ruben. Thanks, Misha, and welcome, ladies and gentlemen, to the first Q&A session of 2023. During the course of last year, we built a company to build your helicopter. We built the team, we built the facilities, we built the know-how. We made transmissions, we made airframes, patterns, molds, tooling, equipment, seats, avionics, and engine parts. This year, you're going to watch us build HX50 and GT50. Tonight I'm going to give you an update from across the program covering the four usual areas that we cover. We're going to cover the status of the airframe development, the engine and drivetrain, state-of-the-art digital cockpit, and then an update on the development of our serial production facilities. We showed you at the end of last year the very first HX50 airframe, our first attempt at bringing all of this suite of technologies together. And now what we've been doing since we got back after Christmas is really starting to refine that process to the level that we can deliver repeatable, high-quality aerospace grade structures. So we've been working to improve and develop the infusion strategy. The guys have been doing a lot of work trying different bagging strategies, different approaches to sealing the joints between the different elements of the mold to create the perfect environment for infusion to take place. So part of the trick to getting crisp definition of the edges that form your door apertures, your cargo bay doors, is being able to fill the tight corners that get created in the mold tools that a normal piece of flowing carbon fiber won't want to tuck into. We can use carbon fiber bootlaces, which is really, as you can see here, just a rolled up piece of carbon fiber. Or indeed, we can also look at using intensifiers, which locally pack carbon fiber that allow the vacuum bag to drive the carbon into the corner of the mold. We've brought all of these elements together into the next fuselage. So let's go over and have a look at where we left off fuselage 1, and I'll introduce you to airframe 2. Now, the first stage in all of this is that the primary objective is to make a carbon fiber single piece shell where the infusion is perfect. This is airframe 2. And what we've done here is we've implemented a number of the things that I just discussed in the presentation. So we held the temperature much more carefully, we got a much better vacuum, and as a result, the infusion was a different league. We've started to achieve much better quality of the bootlace edges up here. And you can see this here, down with some of these internal corners and external corners. This is started to look much more like a pressed automotive panel. We've got some foam cores in here. Now, these foam cores weren't made by us. These were cores that we did in parallel with us machining tools, and they're not quite right. However, what we've done, rather than just throw them away, is we've fitted them to the airframe, firstly to give you an impression of what the finished structure is going to look like when these foam cores are covered with carbon, but also what we've used these for technically is to allow us to template all of the B-surface carbon fiber plies. So these foams have been fitted to the airframe, and then the composites team have been in there taking templates, cutting all of the carbon fiber they need, so that when our first set of foams come off the CNC machine, we can go straight to laying up a full trapped foam structure. The sense of security, the strength in these sections, the crash worthiness of these sections, and then also our ability to tune these sections for vibration to give you a nice smooth ride is all enhanced by having the sectional depth to be able to play a tune on where you want to place the natural frequencies. What's the next step? What we've got to do now is to really crystallize the edge details, get rid of the last couple of infusion imperfections, and we're doing that with one more external shell. One of the major benefits of vertical integration is you get also, because you make everything yourself and you make all of the tooling yourself, you make all of the equipment yourself, you control everything. There's lots of carryover from one process to another. What we've done here is we've essentially created we've created a tool that produces one of the glazing panels. I think this is one of the front windows or the front doors. So the whole vacuum form part sits over the top of this. This whole assembly sits on the CNC machine, and then as you saw in the video, the CNC machine will run around this path and trim off the acrylic part, leaving you with a perfectly trimmed windshield panel at very, very low cost. So what does this look like when we actually get into production? One of the most important things to us being able to ramp up and to take full advantage of the technology that exists today but didn't in decades gone past is we need to make the appropriate use of automation. The appropriate use of technology means that you can scale up much more quickly and gives you much better control over key processes that are crucial to quality. And this isn't the only application that we have for robotic support of the production process. The robots will be extensively used throughout the entire composites line and in certain key areas elsewhere. I'm very conscious that over the course of the last few weeks we've talked extensively about the modelage and the composites design, and we haven't talked a lot about another major activity that's going on in the background, which is the revision of the tail boom design, the whole tail section of the helicopter. What we've done is we paused the development of the tail section structure while the aerodynamics of the ducted fan matured and the aerodynamics of the fin and the horizontal stabilizer matured, and then what we've been able to do is pull in all of the learnings from the process development that we've done with the modelage to develop a much more sophisticated design. Let's talk briefly now about GT50. So one of the things that we've kicked off with this year is essentially a program of very, very extensive analysis on the design work that was done last year, including independent expert review of all areas of the engine. A lot of effort over the course of the first month back after Christmas has been going through the first part of this exercise. One of the bits of feedback we had from one of the reviewers was the fact that we need to make sure that things like the sprag clutch are easy to get at because they can fail in service. And what you don't want is to have to remove the engine and then to have to strip major components of the engine to get an integral part of the helicopter drivetrain out of the way. One of the other areas that we're looking at, because we have to do a lot of casting anyway, is the opportunity to cast the impeller to near net shape or potentially even net shape and do a very, very small amount of machining to minimize the time to produce these units and maximize the productivity of our CNC equipment. What I can show you here is this is the very first Hill manufactured bearing that was made right here in DC1 on our equipment to our designs. Okay, so here's something that I've been very excited to share with you over the course of the last few weeks. And what we're going to do now is give you a little walk through some of the things that we've been doing. Very good. So we appear to have an intercom working.
We do indeed.
Very good. So do you want to just show me how the intercom panel works, because that's down on the IPI.
Absolutely. Yeah. So our intercom is a simple 3-mode intercom. We have all, which it's in currently, and so myself as the pilot can hear everyone in the cabin. And so if I were to put this into pilot ISO, then I'm going to
you're going to disappear.
Disappear basically.
And then, but I'm still, so we can't hear Eric, but you can still hear me, and the passengers can still hear me as the co-pilot. Fantastic. And you can use the puck to switch between those the ribbon frequencies.
That's
well,
right. Yeah. Yes.
Fantastic. Okay.
So if we just look here at the first limit power indicator, right now I'm sitting at about 97%, which I can do that all day long. But if I pull a little bit more power here and just edge that up into about 105% here, you can see that turns amber. And we have this sort of pi timer visual effect that gives you the amount of time you have remaining in that power range. And then down at the bottom here, we can see we have a countdown timer that shows you that remaining time.
Okay, let's talk about production for a second, because it's all well and good having these wonderful piece of equipment, but we've got to produce lots of them. We've agreed a planning performance agreement with the planning authorities just to try and ensure that the relative permissions and decisions that come from our local government are made in a timely manner. They're currently targeting a 9th of March decision date to give us the go-ahead on building the factory, and we've done everything that is is legally required of us for this permission to be granted. And we're told that from a compliance point of view, we've done everything we need to do to get this through. When it comes to part manufacture and when it comes to quality and inspection, all the sorts of things that you're seeing on the screen at the moment, to make more helicopters, you simply buy more machines, and it's only the assembly side of things and the bit that involves skilled labour that becomes more challenging. So there's an awful lot of work going on at the moment to ensure that we're ready for the scale up that we know is coming. And to that end, as you can probably imagine, sales have continued to be very, very strong. So we've now sold 606 HX50s, 130 HC50s, which is a total of 736 aircraft in 54 countries.